Voyager 1, NASA's remarkable spacecraft, suddenly stopped working after receiving an unusual message from a nearby star. Scientists think it might be a message from extraterrestrial beings. What could this message really mean? Could it be our first contact with aliens? Join us on this cosmic adventure as we decode what lies beyond the stars and uncover the incredible journey of Voyager 1. In the annals of space exploration, there are few tales as riveting and breathtaking as the one etched by NASA's Voyager 1 spacecraft. It's a story that echoes the dreams and ambitions that captivated the world during the transformative decades of the 1960s and 70s, when humanity cast its gaze upon the vast cosmos. The Voyager 1 mission, a remarkable accomplishment in human ingenuity and exploration, marked the culmination of extensive planning, design, and scientific inquiry. Voyager 1 emerged as a trailblazing pioneer embarking on an extraordinary odyssey through our solar system. This extraordinary creation took the form of a spacecraft with a sophisticated three-axis stabilization system, guided by celestial coordinates and a gyroscopic mechanism. This cutting-edge system played a pivotal role in ensuring that the spacecraft's high-gain antennas remained precisely aligned, facilitating seamless communication with Earth. Recently, however, NASA engineers were baffled when the probe began transmitting signals unlike any previous messages. Voyager 1 had been journeying beyond the heliosphere for over a decade. Scientists now believe these signals are a response from an unidentified star in our galaxy, sent in reply to a message we dispatched 25 years ago. Following this transmission, Voyager 1's behavior became erratic. The reason for this unusual behavior and the message's significance puzzled scientists. This may represent our first contact with an extraterrestrial message. But before we explore this further, let's gain a better understanding of Voyager 1's remarkable journey through space. NASA's Voyager 1 followed in the footsteps of Voyager 2, but it charted a faster course, allowing it to depart the asteroid belt earlier than its twin spacecraft. This feat was achieved on a momentous day, December 15, 1977, when Voyager 1 solidified its status as a pathfinder on an endless journey into the uncharted expanses of space. Voyager 1's sojourn brought it into the realm of Jupiter in April 1978, when it was approximately 165 million miles distant from the gas giant. The images it sent back to Earth by January 1979 offered a vivid glimpse into Jupiter's tumultuous atmosphere, revealing storms and atmospheric phenomena of unparalleled complexity. These snapshots gifted scientists with invaluable insights into the dynamic and compositional aspects of Jupiter's gaseous envelope. During its close encounter with Jupiter, Voyager 1 also bestowed upon us mesmerizing images of the planet's entourage of moons. Among the celestial bodies captured in its lens were Amalthea, Io, Europa, Ganymede, and Callisto. Voyager 1 also unveiled two previously undiscovered moons, Thebe and Métis. However, the most captivating discovery unfolded on Io, where the spacecraft's lenses beheld a world painted in shades of yellow, orange, and brown, adorned with no fewer than 8 volcanoes vigorously expelling material into the cosmic void. This spectacle marked Io as one of the most geologically active bodies in our entire solar neighborhood. After it visited Jupiter, Voyager 1 altered its course on April 9, 1979, gearing up for its next celestial destination, Saturn. Then, on October 10, 1979, it executed another precise maneuver, ensuring it wouldn't collide with Saturn's moon Titan. This course adjustment was of paramount importance, guaranteeing a safe and fruitful encounter with the ring giant of the solar system. When Voyager 1 finally reached Saturn in November 1979, the rendezvous proved every bit as extraordinary as its prior celestial encounters. Armed with a suite of advanced instruments and cameras, the spacecraft embarked on a mission to unveil the mysteries of Saturn's vast atmosphere and its retinue of moons. As Voyager 1 delved into Saturn's enigmatic realm, it uncovered a remarkable revelation. Saturn's upper atmosphere, comprising approximately 7% of its volume, was predominantly infused with helium, while nearly all the rest consisted of hydrogen. This atmospheric composition differed from that of Jupiter, where helium accounted for about 11% of the volume. The intriguing abundance of helium in Saturn's upper atmosphere raised profound questions about the planet's inner workings and heat distribution. Scientists postulated that the denser helium might be slowly descending through Saturn's hydrogen layers, potentially shedding light on Saturn's excess heat emission in comparison to the solar energy it received. Amidst its Saturnian sojourn, Voyager 1 embarked on a moon-hunting expedition, discovering 5 hitherto unknown celestial companions: Titan, Mimas, Enceladus, Tethys, Dione, and Rhea. This momentous discovery significantly expanded our comprehension of Saturn's diverse lunar entourage. The spacecraft's camera lenses captured spellbinding images, unveiling the distinctive traits and surface attributes of these newfound moons. Analyzing incoming data, it became apparent that these moons were primarily composed of water ice, unveiling their icy nature. Among this lunar ensemble, Titan emerged as a standout target for rigorous scientific scrutiny. Titan's allure lay in its thick atmosphere and potential for harboring liquid on its surface. Voyager 1's course was strategically devised to facilitate an optimal flyby of Titan, steering the spacecraft beneath Saturn's south pole and out of the ecliptic plane. This trajectory allowed Voyager 1 to glean invaluable insights into Titan's atmospheric and surface characteristics before it continued its grand odyssey into the uncharted expanses of interstellar space. After its encounter with Saturn, Voyager 1 embarked on a remarkable journey away from our solar system, venturing into the great cosmic unknown. The spacecraft, now hurtling through space at an astonishing speed, covered a distance equivalent to about 3.5 astronomical units, AU, each year. To put this in simpler terms, that's roughly 325 million miles annually. Voyager 1 charted a path that veered at a 35-degree angle upward from the ecliptic plane, the orbital plane in which most planets in our solar system reside. This trajectory allowed it to diverge from the Sun's path relative to neighboring stars. However, due to the specific course requirements for its upcoming flyby of Titan, Saturn's enigmatic moon, the spacecraft bypassed Uranus and Neptune, two intriguing outer planets that remained unexplored by Voyager 1. Then, in the year 1990, a momentous occasion unfolded in the annals of space exploration. Voyager 1, positioned at a staggering distance of approximately $40 from the Sun, equivalent to around 3.7 billion miles, executed a breathtaking maneuver. It swiveled its cameras back towards the heart of our solar system, capturing images of the Sun and its surrounding planets. This was a truly historic event, marking the first time in human history that we beheld our celestial neighborhood from the vantage point of outer space. From the mosaic of images acquired during this extraordinary endeavor, scientists crafted something of profound significance: the iconic pale blue dot. This poignant image, forever etched in the annals of science, was made famous by the renowned scientist Carl Sagan, who not only lent his expertise to the Voyager mission but also shared his passion for the cosmos with the world through his teachings at Cornell University. Although Dr. Sagan is no longer with us, his enduring legacy continues to inspire people across the globe. This particular snapshot is often referred to as the Solar System Family Portrait, capturing the essence of our cosmic neighborhood. However, it's important to note that this portrait omitted Mercury, concealed in the Sun's radiant glow, and Mars, shrouded in darkness during Voyager 1's gaze. Following this monumental photographic expedition, the curtain fell on the cameras aboard both Voyager spacecraft. This measure was taken to conserve power and memory, as they embarked on their historic journey into the uncharted realm of interstellar space. In the annals of space exploration, February 17, 1998, marks a momentous date. On this day, Voyager 1 achieved a milestone that left an indelible mark on human spacefaring history. It became the most distant human-made object in existence, eclipsing the previous record held by Pioneer 10, as it ventured to a distance of $69.40 from the Sun. Then, on December 16, 2004, Voyager scientists made a significant announcement. Voyager 1 had detected high magnetic field values at a distance of $94, signaling its entry into a region known as the termination shock, marking the boundary where the solar wind begins to slow down and interact with the surrounding interstellar medium. Voyager 1 had officially entered the heliosheath, a transitional region beyond the termination shock. The crowning achievement came on August 25, 2012, when Voyager 1 etched its name in the annals of space exploration once more. It became the first spacecraft in history to break free from the confines of the heliosphere and venture into the vast expanse of interstellar space. In this new frontier, Voyager 1 unveiled unexpected secrets about the interstellar medium, recording the faint hum of space between the stars. But this historic journey into interstellar space came with its challenges. Voyager 1 began experiencing intermittent communication disruptions with NASA. The signals it has begun transmitting back to Earth puzzled even the brightest minds in NASA. Recently, scientists have posited an intriguing possibility that Voyager may first receive a response from another solar system. This prospect arises from a transmission sent by NASA to Voyager 1 some 25 years ago. This transmission, originally sent to confirm a connection, had a collision with the Voyager 1 spacecraft, causing its signal to scatter in all directions. Scientists now entertain the intriguing possibility that this transmission might have eventually reached the star closest to our solar system, laying the groundwork for a potential exchange of messages with extraterrestrial beings. A dedicated team of scientists hailing from the University of California has reason to believe that they've already intercepted a signal. If intelligent extraterrestrial life exists out there and possesses the means for interstellar travel or communication, scientists speculate that we might receive their response as early as 2029. To unravel the mysteries of these cosmic signals, the researchers employ data transmitted from Earth to various spacecraft, including Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and New Horizons. According to their study featured in the journal Publications of the Astronomical Society, transmissions directed towards Voyager 1, Pioneer 10, and Pioneer 11 have already made contact with at least one star. In recent discoveries, scientists have discerned that transmissions from Voyager 1 have already reached two celestial objects, both identified in 2007. Researchers anticipate that extraterrestrial civilizations may respond to our signals by the year 2033. Nevertheless, some scientists raise the possibility that advanced alien communication methods may have already made contact with us, but their signals might elude our detection. On a different trajectory, Pioneer 10 transmissions encountered a white dwarf star back in 2002. By 2313, Pioneer 10's transmissions are forecasted to engage with a total of 222 stars. The earliest anticipation of a reply message is set for 2029. Meanwhile, transmissions from New Horizons have yet to connect with a star, but they are slated to do so by the year 2119. It's expected that these transmissions will engage with 139 stars by 2338, according to the study. The earliest potential reception of a response message is envisioned for the year 2232. As scientists delve deeper into this fascinating cosmic communication quest, they have also ventured to estimate the specific stars the Pioneer and Voyager spacecraft will encounter in the foreseeable future. Stars aren't fixed in place. They're in constant motion as they journey through the vast expanse of interstellar space. Predicting which stars our interstellar travelers will cross paths with is a challenging task without a precise understanding of their velocities. However, two brilliant minds, Corinne Baylor-Jones from the Max Planck Institute for Astronomy in Germany and Davide Farnocchia from the Jet Propulsion Laboratory in Pasadena, California, have taken on this complex calculation. They've employed a fresh perspective by utilizing a new three-dimensional map that charts the positions and movements of stars within our Milky Way galaxy. For the first time, thanks to this innovative approach, we can now identify the stars that these spacecraft will encounter in the millennia to come. Their analysis reveals that the closest encounters will occur when the spacecraft is at separations of approximately 0.2 to 0.5 parsecs, and these encounters will unfold within the next million years. The foundation for these groundbreaking results is the data collected by the Gaia Space Telescope. Since 2014, Gaia has been stationed about 1.5 million miles from Earth, meticulously recording the positions of over 1 billion celestial objects, encompassing stars, planets, comets, asteroids, quasars, and more. Simultaneously, Gaia has been measuring the velocities of the brightest 150 million of these celestial entities. The culmination of Gaia's observations is an intricate three-dimensional map that vividly portrays the Milky Way galaxy and the intricate dance of celestial objects within it. The version used by Baylor-Jones and Farnocchia for their calculations is the Gaia Data Release 2, or GDR2, representing the most recent and comprehensive edition of this cosmic cartography. By harnessing the power of this map, scientists can predict the future positions of stars in our cosmic neighborhood and then compare these projections with the expected paths of the Pioneer and Voyager spacecraft. This comparison yields a list of stars that the spacecraft is destined to encounter in the coming millennia. For their analysis, Baylor-Jones and Farnocchia define a close encounter as one in which the spacecraft comes within 0.2 to 0.3 parsecs of the celestial body in question. The first spacecraft set to embark on a historic encounter with another star is none other than Pioneer 10, a mission slated to unfold approximately 90,000 years from now. Its destination? The captivating orange-red star known as HIP 117795, nestled in the constellation of Cassiopeia. Pioneer 10 will draw astonishingly close, reaching a proximity of 0.231 parsecs. This momentous flyby promises a tantalizing glimpse of interstellar exploration. But Pioneer 10 is just the trailblazer on this cosmic odyssey. In around 303,000 years, Voyager 1 will gracefully traverse the realms of space to approach a star by the name of TYC 3135-52-1. Positioned at a distance of 0.3 parsecs, this encounter will mark a significant milestone in our pursuit of the unknown. And it doesn't end there. In the grand cosmic calendar, approximately 900,000 years from today, Pioneer 11 will rendezvous with the star TYC 992-192-1, venturing as close as 0.245 parsecs. What's truly captivating about these flybys is their remarkable proximity. They're all set to occur at a distance of less than 1 light-year, and in some instances, they may even graze the outer reaches of these stars' distant cometary orbits. It's a celestial dance between our intrepid spacecraft and the enigmatic stars they're destined to encounter. However, Voyager 2 charts a different trajectory that seems to lead it into a more solitary cosmic future. According to the meticulous calculations of our scientific pioneers, Voyager 2 won't come within 0.3 parsecs of another star over the next 5 million years. Yet, a glimmer of interstellar interaction still beckons. In roughly 42,000 years, Voyager 2 is predicted to approach a star named Ross 248, nestled within the constellation Andromeda. While it won't draw as close as some of its fellow travelers, this moment offers a tantalizing glimpse of the vast cosmic tapestry. As we venture further into the annals of space exploration, the fate of these intrepid interstellar travelers remains an intriguing enigma. They may eventually collide with or be ensnared by the gravitational pull of distant stars, an event that lies on the cosmic horizon. While the precise stellar rendezvous remains shrouded in uncertainty, one thing is clear. These spacecraft have an extraordinary future ahead, with timescales stretching into the unfathomable realm of 10 to the power of 20 years. In these awe-inspiring times, the prospect of encountering advanced alien life beckons on the horizon. Although it's conceivable that we may have missed signals from extraterrestrial beings, owing to the limitations of our current technology, hope persists. The dedicated Voyager team continues to labor diligently to ensure our spacecraft amasses every iota of data possible, maximizing their journey's mileage before the inexorable depletion of their power sources. Thanks for watching. For more mind-blowing videos, check out the next video that pops on your screen.